So we are talking about acceleration. Um, Make sure you have your paper, pencil, all that good stuff. Only write down what is highlighted. I highlighted what you need to write down. Don't write down stuff that's not highlighted. Don't do it. Um, so the acceleration is a rate in which velocity, speed changes. Um, So that is the formula that you would use. Um, so where it says change in speed, um, the first V2 means final velocity, subtract initial velocity. So what you measure at the end and what you measure at the beginning, you subtract it. Then you take that number and then you divide it by the time, which in this case we always do seconds, um, and it will give you your acceleration. So make sure you write that down real quick. Only the highlighted part. So speed and acceleration are not the same. They're not. Acceleration is the change in speed divided by the change in time. So that mathematical formula is what gives you the acceleration. So in this example, it shows a sports car and speed goes from 0 to 60 in 5 seconds. And the reason why they know is because not only has it been tested, but they have used this formula. So the change in speed, which is 60, the change in time, which is 5. So from if it went 0 to 45, then it would be 45 miles per hour instead of 60. So the miles per hour is the top part, and then the seconds, even if it took 10 seconds or 3 seconds, would be at the bottom. And then you would divide it and you get 12 miles per hour / seconds. So within that short time frame, it jumps 12 miles per hour in every second until it gets to 5. So make sure you're only writing the yellow part. So in this example, because garbage trucks are slower, it shows that it takes 15 seconds for the garbage truck to get to 60 miles per hour. So as you see, it took 12 was the end result for the car. And in this instance, it's only 4. So the truck is moving at a slower rate because it has a lot more tons it has to move versus the car. So no matter what, everything changes. Um, it could change the number based on how much the weight is, uh, the shape of the vehicle, or whatever is moving that you are calculating. So in science period, but especially in physics, physics is the main one because physics is a lot of math. Um, we will be going over the different math problems. We will be doing some of the math problems. Now, will we do a million worksheets on it? No, but you will get the gist. Um, this is showing you that speed can be, as you see, it's a straight line. It means there's no acceleration does not change, it stays consistent. Um, but the good way to tell is because they graphed it, they showed it. And then there's different examples of different graphs in there. And it's just pretty much showing that a car just stays at a constant speed. If you put your car on cruise control, for example, and you're driving down 64, 71, 65, that's all highways. Besides Preston Highway and Dixie Highway, stuff like that. So I'm driving down Gene Snyder and I'm going to one side, and the speed limit is 55. Well, if I put it on cruise control, guess what? It stays consistent and nothing's going to change. Now, when I turn cruise control off and I move my foot on the pedal up, that's going to let off on the gas and I'm going to drive slower. If I put my foot down heavy on the pedal for whatever reason, I'm going to speed up. So it will change what I needed to graph on the acceleration, and it also will not show straight line. It'll be totally different. So a positive acceleration adds more speed each second. So that's what I was talking about putting your foot on the gas, that it will add the speed per second. It will change it. So if you put more pressure on the pedal, then it is a positive acceleration and it adds more speed to each second. So write that part down. So negative acceleration subtracts some speed each second, some things get slower. So let's say that I am driving down 64 heading home. So I get a lot of negative acceleration, especially when I go home. When I go to work, it's positive acceleration because there's really nobody on the road. So on my way home, it's about 3:30ish, 3:50 if I'm lucky. I get on 64 and I'm heading home. Most of the time, I will get up to a certain speed and then I will have to slow down because the cars in front of me are braking because it's either red lights, of course, and I don't really see movement. So then I'm going to have to change my speed. because there's really no movement going on. And that's what negative acceleration is, the lack of speed. And some people use deceleration to describe sometimes slowing down. So make sure you write both of them down. Um, so in these examples, it shows that in this graph, they call it position versus time graph. And one example is speeding up, and you see the curve is going from the bottom and rolling around up. And then you see the curve on the opposite side, it goes up and then it starts to flatten out because it is slowing down. So these are what we call curve graphs when they're acceleration, but their curve graphs are also used for other stuff. Um, Acceleration occurs when there is a change in speed, direction, or both. So as you see in one of the examples, the speed can change because the car is going straight and it's going fast. But in the bottom part, the car is kind of tilted. Like the front end is down, but the back is a little up. So it could be going down, heading towards a hill, slope, whatever. And if you're going downhill, your speed increases. When you're going uphill, your speed decreases. Um, but the direction can change because if you go into a curve, you're supposed to slow down. Most people don't, but you're supposed to slow down when you're going into a curve. So that will change the acceleration. Uh, Curve motion. Um, in a projectile, it is an object moving under the influence of only gravity. And the path of the ball shaped curve called a prolora is the way that the ball is moving. So the shape of the ball determined how, from where you kicked and how it's moving, change the velocity of the way it's going. Uh, but you'll dive more deeper into that when you get into high school. Not so much in this unit. We might talk about it in the spring a little bit, but not so much. Um, in the way that it's looking, we are probably going to do more of a review of all this, just like a snippet to go over keywords. But I think that in the spring that we'll just mostly do labs and some worksheets because it's going to be more contact. Um, so contact requires movement, all that good stuff. So we'll do, I think a lot of the labs will have to be done then. Plus, it'll be the end of the year. So I feel like the labs would be a lot better in a review of this versus taking all the notes for that unit. We can go ahead and get it done and get it over. So a circular motion is another type of curved motion. Um, the velocity, it'll change depending on how the direction. Now, if you're moving the ball around, it'll change the speed. But if it is constant, if your hand stays the same as she has her hand in that picture and she does not move, then the speed will change the same and the ball will stay where it is. Now, if she moves her hand or finger any type of way, it'll change. So, so in this example, it's showing the how a connection into something. So usually, just like with the portfolios, I mean not the portfolios, open responses. My bad. In those open responses y'all did about the sales, we did a connection into writing, which means we went from not only science, but we also integrated another subject. Um, so in this part, this is the technology part. So as you can tell, whatever dropped, looks like milk, whatever fluid it is, um, you can see where it landed and when it landed, how it expanded. So a lot of objects move too quick, so the human eye cannot see. Sometimes we'll see a fly fly by. If it's warm in the room, the fly moves faster. If it's colder in the room, it moves slower. Um, but in this case, you can see the image because of the photograph that was taken, and the photograph gives you a still image of what was taken right then and there. Same way with raindrop, drops too fast. You can see it come down, but you really don't see it hit unless you take a picture or take a video and slow it down to the point to where you can see. So the different relationships of graphs, ways to show between two variables is to use a graph. Um, a graph makes it easy to see changes in one variable because changes in the other variable and the effect. So the cause and the effect. Um, and that's a good way to also show your data when you're doing an experiment or anything, especially scientific, or you're trying to prove something. Graphs usually help out, especially with numbers. So in this instance, we're using runner's position versus time. To graph the data, you put the position on the vertical y-axis, which is over, let's see if I can use the little, okay, I got it. So this is the vertical, that's the y-axis. And the time, which is down here, is in the horizontal axis. So what we're looking for is we will, depends on how many runners we have. So we'll write their position and then we'll write the time that they came in and we will put it on a graph. This one looks like they only use 3 people maybe um, to show um, the time and the position in that necessary in that race. Um, so like we talked about earlier, um, an object at a consistent speed. When that car went, if you put yourself on cruise control, how it does not change. Um, so in this instant, the graphing would just be a straight line across because there's no rate of change. Um, in this instant, So with graphing, the most important part is you always choose what your dependent and independent variable is. That is why we talked about the scientific method and the difference between those, because you were going to need this later on. Um, so the dependent variable goes on the y-axis, which is the one that goes straight up and down, your vertical axis. The independent variable goes on your x-axis, which is horizontal, which is the bottom part. And you make a scale for each axis by counting boxes to fit your largest value. Count by multiples of 5, 2, whatever you feel comfortable when you're plotting your graph. And put each point and finding on the x, match it up, put it over, put a dot. Uh, so slope. Now we are not going to get into the mathematical part of slope. I will let the eighth grade math teachers do that, and your freshman math teacher, and whoever you'll have for algebra 2 and college algebra. It is not me. But we do use slope in science. Um, and the slope is usually determined like the steepness. There's a mathematical formula for it. But we're not going to go. But in this instance, you see, based on the results, it created a slope. And the slope formula is rise over run. So y2 subtract y1 divided by x2 subtract x1. And you use y equals mx plus b. And just like we talked about, rise over run. So if the position in this case was 10 meters and you ran 10 meters in 5 seconds. So each meter, so each half of that you were running. So 2 meters / seconds. So the speed was 2. That's how long it took you to get to point A to point B based on the formula. So slope is the ratio of rise vertical change to the run of horizontal change. The slope is therefore a distance divided by a time, which equals speed. That's a mouthful. So the position versus time graph is position on the y-axis, which is right here. This is the y-axis. And the time is on the x-axis. These graphs each show the same event. What difference do you notice? That the position that they started from or where they're running from is tracked in one graph versus how long it took. In the other graph, instead of looking at the position, they looked at the speed, and the speed stayed constant, as we can tell. That's why it was a straight line versus how long it took. So it still took the same 60 seconds to get there, but this shows how they got there by speed and where they started at versus their position. A speed versus time graph can also be used to find the distance the object has traveled. I want to say this is one of your last slides. Also, make sure you save your notes. You will be having a vocab test either next week or the week after. Um, so make sure you save them. And you definitely won't be using your notes. It's just going to be like a spelling test. Um, and you will know the words prior to promise. So you're definitely done with these notes. Make sure you save them. Make sure you push the chairs in. Make sure there's no trash on the floor. And you're done for the day.